right, we're going over the homework to start number 9. I'll probably actually not record me doing homework, sorry. All right, for KAP today we have 2 little mini lessons that we are going to walk/run through. The most important thing to take away from this lesson is your star chart. Everyone raise the star chart. What does Miss Idle call this star chart? Our best friend. Why do I call it our best friend? Because it gives us answers. Very good. Awesome. Okay, so we're going to be reunited with our besties. For KAP, I'm going to be giving you all the 7th grade star chart because we're going to use more than just what's on the 6th grade star chart. Quickly. Where do I get my best friend? At the drawer at the pickup table, like everyone else. Thank you. All right, so you will notice on the 7th grade star chart that there are tons of formulas. Some of them we did talk about, some of them we didn't talk about this year, and that's because you'll do the other half of 7th grade next year. What we're going to be focusing on is like this middle chunk. Again, we're not going to be talking about all of it, but we're going to be using quite a bit of it, okay? We're going to be doing area of all these different shapes. So let's hit the ground running. First, we're going to review shapes from elementary school, different attributes to those things. Today, we're going to be looking at quadrilaterals. Quad means 4. We're going to be looking at 4-sided shapes. We're also going to look at triangles, but we're going to start with those quadrilaterals. So I think of this sort of as a family tree, like the different characteristics carry through the different branches that happen, and stuff like that. So from quadrilaterals, you can split them into 2 types of shapes, either trapezoids or parallelograms. A trapezoid, the unique characteristic about it is that it has one set of parallel sides. One set of parallel sides. Okay. In geometry, you know how we showed congruence of sides, like to show 2 equal sides, we use the tick marks. Y'all remember that? Okay. There is a symbol for parallel. It is a little arrow. So on a trapezoid, like in this one specifically, the top and the bottom, those sides are parallel. Do y'all agree with that? Okay. So to show that, you can put little arrows. They can either be just like pointing arrows, or you can fill them in. It doesn't matter. So I'm not going to fill it in because it makes me uncomfortable. When I do that, it shows that those 2 sides are parallel. Okay. Obviously, they have 4 sides because they stem off of the quadrilateral. Okay. So that's trapezoids. On the opposite side of trapezoids are parallelograms. What do you think is unique about parallelograms? They have 2 sets of parallel sides.
They never bump into each other.
The parallel sides, correct. Parallel sides. Parallel means they never bump into each other, like on the set. Okay? So to show those parallel sides, again, I could say that the top and the bottom are parallel. And then this is where it sort of relates to the tick marks. The sides are also parallel, but I can't put 1 arrow. I'm going to put 2 arrows saying that those 2 are parallel. Do you see how that relates to the tick marks? Yes, no, maybe? Okay, yes.
So are tick marks just for triangles?
No, tick marks can be used for any shape of the equivalent length. No, tick marks show equivalent length. These arrows show parallel. The different symbols mean different things, but you can use them on different shapes. Okay, good question. All right, parallelograms, 2 sets of parallel sides. Again, this characteristic is going to carry on through the rest of that little stemming off the chart. Okay, you'll also notice that they all take on quadrilaterals. Okay, from parallelograms, again, you can have just plain parallelograms, but then you can make more unique shapes. With a rectangle, do they still have the 2 sets of parallel sides? Yes, okay, top and bottom, those are parallel, sides are also parallel. But what else is unique about rectangles versus if I'm looking at the parallelogram versus a rectangle? What else could you say, Maria?
There's 4 right angles.
Very good. They have 4 right angles. Okay, so you can go, remember we can add those little squares to show the right angles. You could also, if you wanted to, just if you wanted to mark this rectangle up like crazy, you could say that they also have congruent sides. You could say like, oh, that side is equal to that side. 2 tick marks. Okay, you could. I'm not making you. I'm just saying it is an option. Technically, parallelograms will also have 2 sets of congruent sides. I'm not going into that. Okay. Again, the thing I'm focusing on is those 4 right angles. Now, not with right angles. Obviously, you can see a rhombus does not have 4 right angles, but it does have, well, that we already know because of the parallels. But what's unique to a rhombus, Carolyn? Not, that is a true statement, but not what we're looking for. Yeah?
I don't know, should we separate it in triangles?
Yeah, but no. Okay. Unique thing about a rhombus, it has 4 equal sides.
Oh, right.
Okay? And so because of that, you take the 4 right angles and the 4 equal sides, and together we have a square. So we have those 4 congruent sides and those 4 right angles, and that is what makes a square. Wow. Okay, 4 right angles. Not my favorite. 4 right angles, 4 congruent sides. We gotta keep moving. Thank you for your feedback. Okay, so this sort of ties into all squares are rectangles, but not all rectangles fall into squares. There are rectangles with not equal sides, so they're not all squares, but all squares do have 4 right angles, do have 2 sets of parallel sides. Okay, moving on quickly.
So how does parallelogram have a lot of things coming down?
Yeah.
Does it probably not have a finger shape that's all into it?
No. No. Yep. Great question. No, trapezoids there's not really a lot of things that we're trying to make them anything that breaks off.
So wait,
Yes, thank you for raising your hand.
it can be divided into 3 triangles.
Sure. Yes, but we're not going to talk about that. Anything can be broken down into shapes, but we want rules. Yes. Quickly.
So a rectangle is a square, but a square isn't a rectangle?
All squares are rectangles, but not all rectangles are squares. We're moving on because I don't want to focus on that. What I do want to focus on is area. Okay, finding the area of all these shapes. We're not going to do parallelograms, rectangles, squares. We're not going to do rhombuses this year. I don't think you do that honestly until high school because they're not that common of a shape. Everything else is pretty common. Okay. When we go into this area unit, something that is going to be said a lot by Ms. Heidel are the 3 letters FSS. So before we get into the actual lesson, I want to talk about what FSS is. Okay, so over here, right, FSS. This is what I expect to see on every single problem, and you can't say that I've never told you that I need to see this on every single problem because I'm telling you here, day 1 from the start. Okay, what those things mean are F stands for formula. The first S means to substitute. And then lastly, you will solve. I will show you what this looks like. But if I say FSS, what Ms. Heidel is telling you to do is write your then, and then, okay, one more time.
Formula, substitute, solve.
Great. Okay, you will make, I don't care how easy of a problem it is. 6th graders, half the time, the first mistake they'll make is the wrong formula because you don't know what shape it is. Believe me. Okay, so elementary, don't have the formula area equals length times width. Let's look at our star chart real quick. Take your finger, point at the rectangle / parallelogram formula on your star chart. Take your finger, again, not your voice, your finger, put it on that formula. What does it say? It does not say length times width. It says A is equal to BH. Miss Heidel, what are you doing? Okay, it's the same thing, it's just different letters. Okay, you'll see throughout today and tomorrow why we use base. B stands for base and H stands for height. It's the same thing because if I'm looking at the length, that's also talking about the base length. If I'm looking at the width, that's also talking about the height. Length times width is the same as base times height. Okay, if you use length times width, that's great. Awesome. I don't care. It's a formula that you've been taught. Go for it. Okay. I'm always going to use the one that's on your star chart because that's going to be the one that you see on the day of star, and I don't want you to be like freaked out like, what does that mean? Okay. I'm going to say it 12,000 times. Okay. So let's just jump into it. What kind of shape is this? Square. Square, which is also a type of rectangle, which is also a type of parallelogram. Great. Awesome. I'm always going to start with my FSS, starting with my formula. What is the formula for a square? A is equal to BH. Write it down. Bam, you got 2 points right there. Congratulations. Next step is to substitute in my values, replacing any variables with letters that I know. Do I know my base length? Yes. Do I know my height? Yes, so I'm going to substitute. I'm going to say A is equal to 5, 6 times, bam, another 2 points right there. Okay, then solve. Formula, substitute, now let's solve. Just multiply fractions, top times top, bottom times bottom, right side up. I get 25 over 36, bam, another 2 points. Lastly, but not leastly, units. Or simplify, yes, can I simplify this? No. Lastly would be units. When I find the area in elementary school, we learned that it would be feet, not just feet. Square feet. Feet squared. Okay, so again, notice that was like 2 points, 2 points, 2 points, and then another 2 points. If you don't do a part, you will lose points. Okay, if you just give me the answer, that's going to be 2 out of like 8 points. Is that a passing grade? No. No. Show your work. I cannot say this enough. And I'm saying this day 1, lesson 1. Show your work. Okay? Awesome. Do the next 2. Ready, set, go. All right, I'm just doing 1 for time's sake. If you did not get formula, look at your partner's paper. If they didn't put a formula, tell them -2. -2. Ooh. I put okay. All right, cool. Please make sure. I'm just always gonna walk around in a few seconds. I'm moving for speed right now, but in a few minutes I'm gonna be looking around and I'm gonna say -2. I'm gonna say it real loudly to Alex in front of the whole class. So don't do that for a second. All right, moving on. Now we're going to be talking about parallelograms. Everyone on your chart card, take your finger, point the parallelogram formula. Ready to go. It's the same thing. Why is that? Because all rectangles are parallelograms. It's the same formula. This I was going to do a little show and tell. It's really hard to do on the smart board. So I'm going to show and tell my class. You'll still get a lesson. So, yes, they use the same base and height formula. I'll show you all as best I can on this little thing. So, if Miss Lytle, let's see, what should I do it on? Okay, so let's say that I started with this parallelogram right here. I'm just going to trace this line. What I just showed my class is that if I were to take this parallelogram and chop off this triangle, I could move it over, okay, and I chopped this part off. And I've now formed a rectangle. In that rectangle, it still has the same height as before. I have not changed that up and down height. And then the face length, whatever I cut off over here, I just reattach. So it has the same face length. That is why we use the same formula. Okay? So let's go ahead and start with finding the area. Miss Lytle always starts any area problem with my formula. What's the formula? 2 points right there. Ready, set, go. If I don't see you raising, I'm taking off points from your average. Thank you. Okay, let's substitute. Uh-oh. Okay, please stop that noise. I've asked y'all to stop. I don't need to get more points. Thank you. All right, what is missing from my picture? Everything. Numbers, like literally what am I supposed to do? What do y'all think? Count the squares, okay? So if I'm looking at that base length, okay, right there, count it. 1, 2, 3, 4, 5, 6. My base is 6 units. Y'all agree? Okay, my height. Okay, when you go to the doctor's office, when they measure you, you always go into the doctor's office and they always like weigh you and they measure how tall you are, right? Okay, when they measure you, do they measure you straight up and down or do they measure you at a slant? Up and down. They tell you to stand straight up and down and they measure you top to bottom. Again, not at a slant. So if Miss Lytle is looking at this parallelogram and I'm trying to find the height of my parallelogram, am I finding the slant or am I finding the straight up and down? Exactly. The height always has to be what's called perpendicular. Everyone say that word? It must make 90 degrees. It's straight up and down to the base. So we're not finding the slant height. That's cuckoo for cocoa puffs. Okay? We want that straight up and down height. So go ahead and count it. How many did y'all get? 8. Okay, so my height, substitute it in, 6, 8, that would give me 48 units squared. Okay, so when you're calculating area, again, you're trying to figure out all the space that's in that shape. We notice that there's like partial squares over here, but with the formula, it takes into account all the different partial things. It does that math for you. You don't have to sit there and count, okay, 1 1/3, 1 1/8, The formula does that for you, okay? You do not need to count partial things. 48 units squared. Okay, so go ahead, do number 5, pause and play. All right, because I already know some of the first steps. Again, what shape is this? This is a, so that formula is BH, and some of y'all have stopped there because you're like, oh. Okay, substitute, what is my base? 20.8, but then the height is what's getting off. Miss Lytle just said our height is going to be up and down, straight up and down. Again, that spicy word is perpendicular. Everyone say it? Perpendicular. It means a 90 degrees. Which of those makes that straight up and down height? 11.7. Okay, go ahead. All right, here we go. 243.36 units are centimeters squared. If you did not get that correct, the first thing I would check, but probably the most common mistake, is when you get to, you've done your 7, you've done your 1, making sure you put 2 placeholders when you go to that last one. Some people either forget the placeholder altogether or just put 1 placeholder. Okay, check that math. Again, we're going to keep moving because of speed and agility and time. Okay, the last little parallelogram that we're going to look at is this. What is that? That is it's a picture frame, right? Like something like that. Okay, on your star chart, do you see a picture frame formula? No. Okay, because no. So this is where we have to be problem solvers. What can we do in this problem to help us solve? Payman, what are you thinking? Okay. Yeah. Very good. Okay. I see 2 different rectangles. Okay, we've got our big, and then we've got our little rectangle, the inside rectangle. When I find the area of each one, after that, I can just subtract them. Okay? Yes, Miss Lytle expects you to do FSS for both of them. Welcome to the fun party. Okay, so let's ready, set, go. A is equal to BH. That big rectangle, A is equal to awesome job. That's going to give me 96 feet squared. Bam, I'm already done. FSS for the little one, A equals BH. A is equal to 9 and 4. 9 and 4 gives me 36. Subtract the 2.
How do you recognize?
Okay, the reason why Miss Lytle is having you write FSS for both of them. In a few weeks, it's actually going to be after STAR. We are going to have shapes. Miss Lytle is going to give you some weird shapes. Okay, and it's not always going to be a rectangle inside of a rectangle. Maybe it's a house or a triangle inside of a rectangle. And those formulas, will they always be the same 2 formulas? No. Okay, so I'm going to practice now with the easy stuff, so when Miss Lytle spices it up, I have those habits in place. Gucci? All right, moving on. We are now going to look at triangles. So this is not a part of the quadrilateral family, but it's still related to it. Okay? As we know, a triangle is not a quadrilateral, but a triangle, which means it's 3-sided. Very good. Okay, so triangles are actually pretty closely related to parallelograms. You just never know. Okay? The reason is because any parallelogram that you have can always be split exactly in half into 2 triangles. You can take a rectangle, cut it into 2 congruent triangles. You can take a parallelogram, cut it into 2 triangles. Okay, it's the same exact shape. So, therefore, the reason why our formula, let's look at the formula for the triangle. It says, what does it say for a triangle? 1/2 BH. It's taking that BH, that parallelogram formula, and it's just doing 1/2 of it. Okay? You're going to first always, a lot of things stem off of that parallelogram formula, but I'm going to take the whole thing, I'm going to find the whole area, and then I'm going to cut it in half just so I have the triangle part of it. Okay? The B still stands for, the H still stands for, and the height has to be what to the face? What was that word? Perpendicular. Okay, that's going to carry over here. So any parallelogram can be divided into two congruent triangles. Okay? The formula on your star chart is A is equal to 1/2 BH. That is the one that I use 99% of the time. Technically, if you multiply by 1/2, you could also do what with your division? You could divide by 2. You could also do BH divided by 2. Again, I will always use this one because that's the one on your star chart, and I don't want you to be thrown off. Okay, but it's the same thing. It doesn't matter. Okay, so moving right along. Just as a reminder, congruent figures are figures with the same shape and size. They're both triangles with the same dimension. They're both squares with the same dimension. Okay, the base of a triangle can be any side. Honestly, Miss Lytle is going to do some messy math where she does a triangle like this. Oh my God. Where's my base? No, I'm going to make this the base, okay? It can be any side. The base can be any side. And then the height just always has to be what? Perpendicular. Must be perpendicular.
So is the longest side always the base?
Not always. You can make it any side. It could be the shortest side, it can be the longest side, it could be the medium side. Okay? But what has to be true is the height must be perpendicular. Again, that means 90 degrees to that base.
It's my favorite word.
What? Great. Awesome. Okay? So, what kind of shape is that? Triangle. I'm always going to start every area formula with my formula, sorry. Every area problem, I'm going to start with my formula. Okay, so that formula is A equals 1/2 BH. Again, I'm using a different formula because it's a different shape than what we were practicing. Yes?
We just do BH divided by that.
If you do this formula, yeah, great, but you have to write that formula. You have to include that 1/2 or divided by 2. If you do not include the 1/2 or divided by 2, I will take off points because that's not the formula for a triangle. You have to write the whole formula. Okay, good question. All right, formula next is S. It stands for substitute in my values. Oh my gosh, we have to count the boxes in. Okay, I'm going to go ahead and rewrite that 1/2 because it's already a number. My base length is 6. My height is not 3.5, it's a full 4. Okay, again, the formula does those partial area things for you. Count the full. If it goes all the way, it starts here and it goes all the way to the top. That is a full 4. This is a full 6. Okay, bam. Now, here come those properties again. Those beloved properties are my favorite things, honestly. Okay, because of the commutative property of multiplication, I can multiply in whatever order I want to. Okay, this is all multiplication. 1/2 times 6 times 4. So that means that I could do it right to left. Okay, I could do 1/2 of 6. What's 1/2 of 6? 3. Okay, if I see a friendly like, ooh, get it out of the way, get rid of that fraction. 1/2 of 6. Again, I slash them when I show that I use them. I'm gonna write 3. 3 times 4 is 12. Okay, now pause. You can just watch this. You don't have to write this down. I'm gonna do it in a different order. Okay, I'm gonna have 1/2 6 times 4. What if Miss Lytle was like, okay, let's pretend 6 is an odd number and I can't do 1/2 of it. Could I do 1/2 of 4? What's 1/2 of 4? 2. Okay, so I'm going to slash those out, saying that I've used them. 6 times 2 is 12. Okay, but let's pretend that they're both odd numbers. Okay, what if I did 1/2 of 6 times 4? What if I did my full numbers first? 6 times 4 is 24. What's half of 24? Doesn't matter what order I do it. No. Okay, I always try to get rid of that fraction as soon as possible. I'm just like Alex, I read it all. Okay, I'm not that scared of fractions, but I also want to get rid of it if I can. Okay, if I see a way that I can 1/2 something, I get rid of it, slash it out, say bye-bye. Thanks for coming, go away quickly, bye. Okay, you all see that? Let the fractions be free. Okay, what am I missing from my answer? Nope. Unit square. Gucci? All right. Miss Lyle did X Games mode. Oh my god. What's my base? Is my base on the bottom? No. Because watch. Y'all ready? Actually, this is more of a real life experience. Okay, I'll try and do this on smartboard because my class was thoroughly impressed. Okay. This is a triangle. Miss Lionel, there's no base. Okay, ready? Are we holding on? Oh my god, you can turn the paper around. Thank you. Okay? Literally, it does not matter which side. The top can be the base, but the height always has to be perpendicular. It doesn't have to be up and down. Okay? Because Miss Lytle could really mess you up and do this. Okay? If it gives me this is my base, this is my height, even though it's sideways. And you're like, what are you doing? It has to be perpendicular. All right, so let's do this together. What kind of shape is it? What's the formula? Let's substitute. A equals 1/2. 12.1. 6.4. Can I get rid of that fraction anywhere? I can do 6.4. What's happened to 6.4? 3.2. Get rid of this. 1/2 of that. Again, always slash it to show that you use it. You can't use it again. Okay? Again, it doesn't matter which one you do 1/2 on, but you can't use it twice. You can't do 1/2 of the first one and 1/2 of the second one. You cannot do that. Okay? So that's why I slashed it out. So that's going to be 12.1 times 3.2. That. Give me a second. Oh my god. Area equals. Okay. Again, I cannot say no. 2 points. 2 points. 2 points. 2 points. Don't be a 2 point. Like this is just a 2 point. All right. Last one that I'm going to do with you is number 3 on the back. Last one I'm going to do is number 3 on the back. Look at it, stare at it, read it. Tell me what's different. Will, what do you see? What's different? Oh yeah, go for it. I don't know. 40 something. Yes. Okay. I noticed this triangle is a right angle. Great. What else, Carolyn? They're trying to find the base. They gave us the area, but they didn't give us the base. Guess what? Miss Little's such a good teacher, she's already taught you how to solve this problem. Okay? Because it's an area problem, and we always start with formula. What kind of shape is it, and what's the formula for it? Okay, let's start there. A is equal to 1/2 BH. We always start the same way. That's why Miss Lytle has you do it, FSS, because it actually helps with all kinds of problems. Now we substitute. The thing that's different is, do we already know our A value? Yes. Okay, so substitute that in. So it's going to be 24.9 is equal to 1/2. I don't know what B is, but I do know that H is 6. All right, so let's look here. So my B, my variable is sort of in the middle, but could I go ahead and do 1/2 of 6? Yes, I can. What's 1/2 of 6? 3. So I'm going to rewrite that. 24.9 is equal to 3B. Hey, look, that looks like something we've seen before. How do I get B by itself? Divide by 3. Ready, set, up. Okay, my answer is 8.3 centimeters, not square because it's just the base length. Now, someone asked if we go back to this. don't write this, but just watch. 24.9 is equal to 1 KAP B times 6. Okay, Tanner has said, couldn't we multiply both sides by 2? Yes. Okay, this is not the way that I typically do it, but if I wanted to get rid of this fraction, and I did want to get rid of this, to get rid of fractions, if you remember, is to multiply both sides by the reciprocal, times 2 and times 2. Because when you do 1/2 of 2, you'll be left with 6b. And then when you multiply that, give me a second, 24.9 to 18.9, you get 49.8. Then if you divide both sides by 6, 49.8 divided by 6 goes in 8 times to give you 48. 8 goes in 3 times. Do we get the same answer? Yes. I think it's more work because I'm multiplying by a decimal and dividing by a decimal, where I could have just done it in one step. That's not always the easiest way, but it's whatever works for you. But I try and do it in that easiest way. This is in red. This is what I use. Okay, I'm just showing you you can. All right. So we feel pretty okay about today's lessons. Okay. Sorry, we were going pretty fast. What I want you to work on is wherever it says partner practice, you're working on that. For those of y'all at home, once you get through that, check it with your key on Canvas, and then that homework is going to be the homework part. And there's some of those weird figures. See? Fun. Have fun.